Hi, and welcome to Module 7. I'm your professor, Dr. English Dowdell. So this week, we build on our modular programming by introducing functions. Now, functions are the tools that let us package logic, give it input, and then get some kind of result back. Now, by the end of this lecture, you should be able to describe how functions differ from modules, explain parameters and return values, write clear pseudocode with functions, and then sketch a simple data flow diagram for them. So these are our goals for this week. We want to focus on understanding why functions matter and how to express them clearly. So we're going to learn how to describe how functions differ from modules, explain parameters and return values, write pseudocode using functions, and then, like I said, diagram a data flow for our function. Okay, so let's talk about what a function is and how it differs from a module. So a module, remember, is a named block of steps that organize logic. So think of modules as the chapters of a book. Each chapter focuses on like one part of the story. Now, a function is sort of a special kind of module that will accept parameters. The that's the input data, that you give it, and then it returns a single result to like whoever or whatever called it. So all functions are modules, but not all modules are functions. Now, the big difference is that, again, a function promises a result back to the caller. So if you call a function, you expect some kind of value to come back. And this value is produced from the parameters and whatever the processing steps are that are inside of that function. So the key point I want you to kind of remember is that parameters will go in, okay, and a function value comes out. If it doesn't return a value, then it's not acting like a function, it's just a procedure or just a regular module. Okay, so an analogy would be, think of like a vending machine. Okay, so you're going to put money in, you're going to push a button, that's like passing the parameters, putting that money in. And then the vending machine is going to process your request and then return a snack. Okay, and that's exactly what a function does. Okay, same thing for like ordering coffee. You're going to order the coffee. The barista is going to, produce that, pour the coffee, whatever it is. And then the barista is going to hand it back to you. So you're going to get some kind of return. Okay, now when we talk about parameters, this is how we send data in. Okay, so parameters, they're the placeholders in the function's definition. So when we call a function, we pass what we call arguments. Okay, the actual values that are going to fill those placeholders. Now, two common mistakes that a lot of beginners make is one, mixing up the order of the parameters. The order must match the function's definition. Okay, and also another mistake is made is passing the wrong type of data, like say passing text when the logic really kind of expects a number. Okay, so if we look at this example here, um, the function will have, say for instance, this function here is called calculate area. Okay, and it has two parameters. It has a width parameter and it has a height parameter. And what it's going to do is it's going to return a number. Okay, so inside the function, what happens is the width and the height, again, these are the different parameters. Okay, and when I call it, it's going to calculate it. So when I go to call this function, this is how I call it. I call it by its name. I feed in arguments, okay, for the parameters. So for the width, I'm feeding in the argument of 8. For the height, I'm feeding in the argument of 3. These are the arguments, okay? And this is what it's going to take. It's going to take this as the input. Another example would be like, um, imagine if you had a function called make sandwich, okay? And then the parameters were the bread and the filling, okay? All right, so those would be your parameters, okay? Those are the two inputs that the function is going to accept, okay? And then what do you think that the function is going to return? Okay, so think of it, like I said, an input output recipe. So it's going to return a sandwich. Okay, the results is going to create, it's going to combine the bread and the filling, whatever the processing is for making the sandwich, and then it's going to return that sandwich. Okay, so again, we're going to have parameters, and then we feed those parameters arguments. Okay, and then it's going to return some kind of value. But that's what a parameter is. Okay, so that's the parameter. Now the return value, okay, that's what we're getting back. The return value is the single result that a function hands us back. Okay, so after, say, the function computes something, okay, if it's adding, it's processing, whatever the case is, then it uses the return statement, okay, to send the value back to the caller. Okay, so whatever called this function, it's going to return the total. Okay. So some of the mistakes that I see with this is forgetting to return, then wondering, why the caller didn't receive anything, you know, or another mistake is using print inside of the function instead of returning. Okay, printing is an output for the user. Return is the output for the program. Okay. So again, think of ordering at a coffee shop. You're going to hand the cashier your order and money. Those are the parameters. And then the barista is going to make your coffee and then hand it back to you. Okay. That's going to be your return value. Okay. Without that hand back, the process is going to feel incomplete, right? So here's sort of like an example here. Okay, so if we say sum is equal to, in this sum is equal to, we want to use this function to add 5 and 4. Okay, so if we add 5 and 4, then sum, it's going to return what? 9. 5 and 4 added together is 9, because that's what we're doing up here. Look at our function. Okay, so our function is saying that we're returning a number. So we're saying in the pseudocode, this is pseudocode, okay? We're setting the total equals a plus b. So whatever parameters, these are the parameters, whatever the arguments that we feed in for a and b, they're going to add them up here. A is going to go here, plus b is going to go here. And then it's going to, these added together is going to set this total variable, okay? And then we're going to return that total variable, okay? And it's going to have that's in it, it keeps going. So then here, what we're doing in the main module, so this is going to return that 9, okay, because we're adding 5 and 4, adding 5 and 4. This is 9. And then we're saying display the sum is, and then we're using our return value within this sentence, okay? So again, we've got the parameters. We've got A is going to be equal to 5, okay? B is going to be equal to 4. They go into the function, okay, as arguments. And then the function is going to return 9. Okay, so this function is going to return 9. Okay, and then this main module here is going to store 9 in the sum variable, and then it's going to display it. Okay, and something similar. So if you're using Python, now this is pseudocode. So if you're using Python, the same thing. This is our function. Okay, very similar to what we've got here, but it's in Python. And so what we're doing is we're calling the add 5 and 4, okay, which again is going to return, if we do it here, it's going to return 9. So that means that some result is going to be 9, and that's where main is going to store that. It's going to store it in this variable, okay? And then the program is going to print out the sum is 9. Okay. All right. So that's how we have to have that function. That function has to return a value, and then we utilize that returned value within our main function or our main module here. Okay. Now here's the structure that we're going to be using in this course for function pseudocode. So feel free to copy this pattern, pause this and copy this pattern into your assignment. So basically you'll have the function is going to be, it starts with the keyword function, has the name of the function, so whatever the function name is, and has whatever parameters. We can have one parameter, we can have two parameters, we can have multiple parameters. Okay, and then what we do is within this function, we do some steps. So, you're going to describe, say, the purpose of the function, maybe declare any local variables if you need it, perform like whatever calculations or decisions, using the parameters, okay? And then you're going to return a single result, okay? And then in your main module, you're going to call that function. Okay, so here we're calling this function, okay? And then we're going to capture the results, the result value, and then, we'll decide what we want to do with it. Okay, so in this example, we're calling the function, feeding in arguments for the x and y, the two parameters. So we're feeding in x for the parameter 1 and y for parameter 2. And then whatever the return value is of this function, we're storing it in this variable here, the results variable, okay? And then we're doing something with it. Like for instance, here we're just displaying it. Now, one of the things I want you to make sure that you're doing is use indents, okay? Make sure that you use indents like I'm doing here. Also, use comments if you need to, okay, to kind of explain it. Because sometimes we'll write functions and, 2 months later, we kind of forget what exactly that function is going to do. So, try to comment things when you can, okay? And then make sure that you name things clearly, make sure that the function name, has something, clear. Now, these are just placeholders, but make sure like your parameter names, they should reveal like whatever the purpose is, okay? So that if somebody's looking at your function, okay, they can understand what that function is going to do by kind of looking at the name. Okay, and we don't use spaces in our function names. Okay, if you have to use an underscore, it's fine, but don't use any spaces. And then, like I said, your parameters, make sure that your parameter names kind of reveal. So if it's a width and a height, call it width and height. We don't do, these are just placeholders, parameter 1, parameter 2. Make sure that they're descriptive. Okay, so like I said, if somebody's looking at your function, or either if you're looking at your function, like months later, you understand what this function does and what parameters it's looking for. Okay, so I just wanted to show you a couple examples. So for instance, we've got this function called getMax, and it's asking for two parameters, okay? And so we're saying if A is greater than or equal to B, then return A, or else return B. So here, based on like the condition, okay, we're either returning A or returning B. So you can have, your function is going to only have one return, but that return can be based on, say, maybe a condition like this one is. And so the way that we use this function is here in our main module, we're saying set first is equal to 12, set second to equal to 9, and then set bigger, which is we're setting the variables, is equal to whatever the return value is of this get max. So one is going to be 12, okay, the second is going to be 9, and so it's going to compare 12. Is 12 greater than or equal to 9? Then you're going to return, of course, 12, okay? And so then what happens is whatever that return value, which is going to be 12, is going to get stored into this bigger variable. And then we're saying now this module is saying, okay, display bigger number is, and then it'll feed in 12 here. Okay. That's one example. Okay, here's another example where we're basically applying a simple percentage. So here we're saying apply percentage. We're asking for the base and the percent. And then we're taking that and we're doing some calculations with it. And the results of that calculation is going to be stored in the variable total. Okay, and then that's going to be the value that's going to be returned when someone calls this function. Okay, so here in module main, we're setting the variables for base and for percent. We're feeding that into the function as arguments. Okay, and then once the function gets performs and gets the return value, we're taking that return value of that function, storing it into the variable new total, and then we're saying, okay, now display new total is, and then whatever the value is of new total. So that's your pseudocode, for using as far as this function and creating this function and then utilizing it in our main module. Now you can also have, here's another example where we've actually got two functions that are being called in this main. And when we go to utilize this add fee, we're actually utilizing the return value of this first function. So, we can create modules such as that. Also, functions can also call other functions. So, this is really kind of great for like keeping each function small and focused. So, for example, we could have like one function that might compute a subtotal. And then another might compute the tax, and then maybe a third, might add them together by calling, the first two. So, you can have functions inside of functions, okay? So think of a like a restaurant kitchen. One cook makes the sauce, another makes the pasta, and then the head chef, puts them together on the plate. Again, functions can call other functions in this same way. In the previous weeks, we've actually created a flow chart, okay, to represent as far as our programs. But let's talk about what a data flow diagram is. So a data flow diagram, this is a visual that shows how data moves through a program. Okay, so it's related to data. So instead of focusing on like the step by step, like a flow chart does, a data flow diagram or a DFD, it focuses on the input and the output of a function. And it makes it clear like what data each part of the program needs, how it's going to be transformed, and then what value is going to be returned. And this helps us to develop clean and well-defined functions. Okay, so you're going to be in this week's part of this week's assignment is you're going to be creating a data flow diagram. So the data flow diagrams that I want you to create or that you're going to be creating, I want you to keep it simple. Okay, but the thing is, what you want to do is you want to label everything. Okay, basically the goal is again to show like what data goes into the function. Okay, remember these are our parameters. Okay, so we want to show what data goes in. We want to show how the data moves between, like if we've got multiple functions or modules, so we want to show how it moves, and then we want to show what comes out as a return value. So again, imagine that you're writing a simple program that calculates a student's final grade. So at a high level, the program is going to need two pieces of information, okay? It's going to need the student's test scores, okay, and then the weighting factor, that's going to determine like how much these scores count, say, toward the final grade. So in our program, the main module is going to control the process. Okay, the main module is going to control the process. And first, what it's going to do is it's going to gather the test scores. So, for example, it might gather a list like 85, 95, 78, 92, whatever the case is. Next, it's going to apply a weight. So, for example, maybe 0.06, meaning that the test counts for 60%, of the overall grade. Okay. And then the main module is then going to use say maybe other functions behind the scene, such as maybe one that's going to compute the average and another one to apply the weight. Okay. Um, but what I want you to do is we're going to keep this at a level O perspective. That means that we don't really need to see the details. So this is like the level O perspective of what I just kind of described. So basically, the user, whoever the teacher, whoever the instructor is going to, or the application is going to input the test scores and the weight. Okay, and then the main menu, this is going to be where our processing is going to go. This is our program, okay? And then the output, after everything gets processed, is going to be the final grade. Now, like I said, there's a lot that's going to go behind the scenes here, but I want you to keep, when you do your assignment, I want you to keep it at this level O data flow diagram, okay? This is exactly how like the level 0 data flow diagram shows. It shows a single process, a bubble for like the system, which is like the main, and then it shows arrows for the data flow. So there's two things that flow into the main, from whatever the user input or the application input. Okay, and then we have an arrow that's the result that flows out. Okay, now you could diagram it at a level 1. This is a level 1 where we kind of break down the major process into our sub-processes. In this case, this is going to be our individual functions. I'm not asking you to do that for this assignment. Okay, I'll provide some resources for learning how we would do this at different levels. There's different levels of the data flow diagram, but this is just an example of level 1 where we've broken down this main. So again, this is the one that I'm wanting you to do, but if you want to challenge yourself and do level 1, you can. But again, the user inputs the test scores and the weight. It goes into the main, and then what happens behind the scenes or within main then sends the test scores to the compute average function. And that compute average function is going to send back the average. Okay, then main is going to take that average, add it to the weight, okay, that it was sent, and send it to this function that's called apply weight. Okay, and then apply weight is going to send back the final grade, and then main is going to send back that final grade to the user input. Okay, so again, this is a level 1 where we've taken, broken down the major process. Now if there was maybe if compute average was made up of maybe a couple of other functions, then that could take us to a level 2 where we branch off into that. So again, like I said, this is the only one that I'm expecting you to do. However, if you want to challenge yourself, in the assignment and actually break down main into um, whatever functions it's calling, then you can do that. The important thing is though, is again, to label everything. Okay, make sure you're labeling like what data, because again, this is a data flow diagram. So we want to show how that data is flowing. Okay, test scores are going into main, weight is going into main. In this instance, test scores is going into compute average, and we're getting an average back. That data is coming back, and then we're taking that, adding it to the weight, and moving it to the apply function, apply weight function, and then apply weight function's doing whatever it's doing, its calculations, and then it's going to send back the data, the final grade data, and then main is going to send that back to the original caller or the user. Okay, so I wanted to talk about some common pitfalls and how to avoid them. So these are some of the common issues that I see in beginner function pseudocode. Okay, one is printing instead of returning. If a function is supposed to return, then you need to use the return keyword. Okay, you can print in main, after you capture the value, but in the function, you need to use the return keyword. Okay, the other is forgetting to store the returned value or returning the result. So when calling a function, then you want to do set result equals whatever the function name and then the arguments so that you would be able to see it later. So look at some of the examples that I gave you. Okay. The other is the parameter order being mismatched. Okay, so you define the parameters in a logical order, right? So when you pass those arguments, it needs to be in the same order. So if my parameters are width, comma, height, then I need to pass in as an argument what the width is and then what the height is. I can't, switch those around. Okay. The other is using vague names like calculate letter or compute, I'm sorry, like just calculate it or something like that. We want to use names that are more specific that when we look at the function, we understand what it's doing. So like calculate letter, compute total with tip, um, convert to census or check is logic value or something like that. But you want to use names that aren't vague, okay? And that's for function names as well as for parameter names. Okay, and then trying to return multiple values in one function. That's another mistake that I see. You need to keep it simple. One function, one return value. If you need multiple results, then return one primary result and then compute the rest in the caller, or write another function. Okay, there's other ways of doing it as well, but I want you to keep it simple. Okay. Okay, so for in the assignment, I'm going to give you a few scenarios. Okay, so you're going to choose one of those scenarios. Say it'll be like either grade a calculate, create a calculator, or I'm sorry, it calculate like a grade. It'll be maybe a meal cost calculator that you're creating, maybe a temperature converter or a basic login check or something, or you can reuse your module 6 problem, as long as you implement it with functions that take some kind of parameter, and again, have a return value. Okay, so part one is going to be you're going to write at least two functions. Okay, so whatever the scenario is, I want you to create at least two functions that's going to support that scenario. And each function should clearly list parameters and finish with a return. Okay, just like what I've been showing you. Then you're going to include a main module that prepares sample input values, okay? And then you're going to call your function and then return the results, return the results, okay? And then finally display or use those results. So look at some of the examples that I've given you. You want to have two functions. You want to have that main module that is going to be utilizing both of those functions to support your scenario. And you're going to get that return from those two functions into your main module and then do something with that, like maybe print it or something like that. I want you to comment each function to state like what it does and what it expects and what it returns. Okay, and make sure that you keep your logic readable, with indents. So make sure you're using indentation. Okay, just like you've seen in the examples. Okay, so that's part one, pseudocode with two functions. Okay. The second part two, is you're going to create a simple data flow diagram. And again, like I said, you can keep it at level 0, okay, to show how the information is going to move through your program. So you're going to draw out a diagram similar to what I showed you, that shows data flowing into your function as parameters and then flowing back out as a return value. Okay, so make sure that, in your diagram that you're clearly labeling each arrow with like whatever that data name is. So if it's scores or tax rate or temperature, Fahrenheit or whatever, or username or password or whatever it is. And again, keep your diagram minimal. Now, if you want to do a level 1, like I showed you an example where you're breaking down the main module into the two different functions, you can do that, but I'm not requesting that you do that. I just want you to keep it level. Your goal is basically, I want you to focus on the movement of the data, not so much of the inner workings of the function. Okay, so I just want to show how that data moves in. So look at the examples that I've showed in this lecture. Okay. So I've given you some examples, but I wanted to kind of give you a reusable kind of template that you can adapt to any scenario. So like for instance, this one is compute and return. So what we'd have is the keyword function. Okay, this, and again, this is pseudocode. Okay, you're going to have the name of the function. You're going to indicate like what parameters. Okay, it may have only one parameter. It may have two parameters, whatever the case is. Okay, and then you want to say returns, and then whatever it's going to return, like if is it going to return text or a number or whatever the case is. Then, again, you want to have like your comments. Okay, so, kind of explain like what it actually does, declare any local variables if you need it. And then here is you're going to set result equals, and then this is going to be like, whatever you want to do with input A and input B, whatever you want to do with the parameters. So this is actually what's being processed within the function. And then you're going to return that using the return keyword and say return result. Okay, so this is sort of like a template that you can use to do what process something, whatever it is that you want to do. Okay. Okay, and again, here's another example of like a function. So basically, um, imagine we have one function in your program. Um, we'll name it. You'll whatever your function is, you're going to name it with some kind of like verb phrase. Like calculate. Whatever, convert something, whatever. Or is something valid. And then remember, you're going to list the parameters. And you're going to say out loud like what the single value that it's going to return. That's your starter blueprint. Okay, that's your starter blueprint. Okay, so here's again the pseudocode for that. Okay, so the name of it is going to be calculate final price. Um, you know, Again, that's a verb phrase that we use. Okay, the parameters are going to be, base price, tax rate, and then the return value is going to be the total. So this is also another example, so as you read chapter 6, and it's also good to read, like I said, the textbook, to supplement as far as these lectures. But I want you to pay attention to how the chapter distinguishes procedures from functions. How it shows the parameter list and uses the return values. I want you to mirror that style in your pseudocode so that your work kind of matches the text expectations. Now, if you choose the optional Python enrichment, the pattern is going to be identical. You're going to define a function with parameters, okay, and then have it return a value, and then call it from your main, okay. So again, you just have to kind of take that structure from whatever the chosen scenario of like your pseudocode. Okay, so again, defining, your function. Okay, so for instance, here it is, the same pseudocode that we showed before. Um, we've defined it as a function within Python. Okay, so we're feeding in again the parameters. We're doing some calculation here, storing it in this variable total, and then that's what we're returning when someone calls this function. Okay, so we're defining this function, and then of course, when we do our main, we're going to provide like sample input, call the function, store the return value, and then say print it to the user. Okay. So at the bottom of your file, include the standard Python entry point, so that main runs when you execute this script. So, follow everything that you've been doing with Python up till now, but this is how you would define that function, define a function within Python. You'll find like exact submission steps in the option Python enrichment submission guidelines in the course on that particular page that I've provided for this assignment. Okay, so when you're submitting your assignment, this is sort of like your final checklist, okay, before you submit. So I want you to ask yourself, do your functions take parameters? Okay, have at least one parameter. If you have more than one, that's great. Okay, do they return value? Okay, so do the functions that you've created return a value? Make sure that they return a value. Make sure that you use that return keyword. And then does main call and use those values? Okay, so once the value is returned, it should return back to main, just as in the examples that I've showed you. And then you want to ask yourself, did I draw and label the data flow diagram? Okay, all right. Okay, so for this week, what's next? So after watching this lecture, if you haven't read chapter 6, go ahead and look at chapter 6, and then complete the module 5 assignment, functions with parameters and data flow. Okay, so that's it for module 7. Just kind of remember, functions, they let you write clean, reusable logic, where parameters will go in and then a single result comes out. So, follow the templates that I've provided for you. Keep the names clear and show your data flow. Okay. So I'm excited to see like your pseudocode and your diagrams. Okay. All right. So now head over to this week's module, this week's assignment, and let's go ahead and build it. And have a good week. Okay.